I I'm aware I'm a man who wears many hats. And for about the past decade, between decade and decade and a half, I've been working at complementing models of the sort we've been talking about with novel types of data sources that can help us pin down, ground those models, keep them honest by linking them up with rich sets of data, of incoming data over time. The motivation here is the fact that in many cases we're being asked to model contexts where there's limited empirical data available. Maybe it's aspects associated with maternal-child interaction related to infant maternal mental health. Maybe it's aspects related to people's smoking behavior of e-cigarettes versus regular types of tobacco products. Maybe it's people's behavior with respect to decision making in terms of tobacco use, or indeed in terms of outcomes of diabetic pregnancies, trying to explain the variability. In all of these cases, the evidences often fall short of really what we'd like. We're dealing with these complex health challenges in these increasingly rich decision-oriented simulation models that represent behavior, but often information on some of the key behaviors related to physical activity, nutritional intake, spatial proximity, social context. These factors we know are important in shaping norms, risk of exposure to pathogens, physical activity in terms of as a factor and risk factor associated with, or protective factor associated with obesity, type 2 diabetes, risk of falls, etc. These are all important sort of considerations in the health space, but they're also hard to elicit reliably through traditional instruments. We know since the National Health and Nutrition Examination Survey 3 in the States, which used physical measures of physical activity, and other studies which have looked at nutrition, just how far off a lot of these measures can be when you ask for self-report on these things. People report physical activity levels that often far exceed what they actually are empirically measured as doing using accelerometers. People report much healthier nutritional intake than in fact they are accomplishing through their eating. And the problem is that if we're basing models on an understanding of these behaviors, and if we want to nudge things for the better, we may be basing our models off of unreliable reports and reports that are challenging. An additional motivation here is that if we want to understand the effects of intervention, say the Moving to Opportunity program in the States, which moved low-income individuals to mixed-income areas, if we want to understand their impact on things like, say, obesity levels, there's many pathways by which it might have affected it. And if we can't get accurate self-report on, say, sedentary behavior, physical activity, and people's eating habits, we're going to have a hard time figuring out why such an intervention led to the changes that we see, and a hard time learning from that intervention. So within this area, we'll often be interested in getting a much finer grain understanding of what's going on. And if we're building models, what's going on here as a response to the intervention can be very helpful for building a model that's more useful yet, more helpful in building our understanding of the outcome of possible interventions. Being able to delineate successful nudging of one pathway versus another can help us design more successful interventions with models. So what we've been leveraging in our work here is smartphones and associated sensors, heart rate sensors, for example, weight scales that report weight over something called Bluetooth, so it can be measured by phones, as well as Android-based phones. So we have a system. I'm proud to say it's been adopted by partners around North America. Harvard American Legacy Foundation, University of Michigan, University of New Mexico have all employed our system for health studies, as well as many other partners now. And it's an Android-based app. It runs atop of smartphones, perfectly functioning smartphones. And it undergoes episodic data collection to collect data regarding some of these factors that are otherwise hard to measure. So we have this app running on these phones, and these are some of the studies we've run, many of them here. We're currently talking in a very important way with Alberta Health Services about adaptation for use in Alberta to replace some of the random digit dialing work. We have work going on the housing side with Columbia University, or that's been recently completed. Work going on with partners in England, elsewhere on communicable disease spread, and a variety of studies closer to home, as well as those with legacy and Harvard related to tobacco use. So the basic deal is that you have data collection going on the phone, and periodically and by an opportunistic backhaul, in other words, when you happen to be in touch with Wi-Fi or the cell phone network, you can upload data to a server, and this can be processed. A person can, at any point with this system, go and snooze this system. They can say, I don't want to have my data collected now, but they can also report things proactively, and we'll come to that. So this data backhaul brings the data back to the server for analysis, and we put a real emphasis on being able to easily adapt the system without programming to different contexts, or with an absolute minimum of programming in cases where it's required. So the idea here is IFE phones home, reports data, and it can get a new configuration on the phone. So these are some of the major areas we've tried to address: location, physical activity, spatial proximity, people's context, who's around them, how many people are around them, how close they are. Think about social context for smoking. Think about context for infectious disease transmission within a long-term care facility for nosocomial infection, and physical activity as measured by accelerometry and heart rate, etc. So these are some of the sensors that are commonly built into phones. More recent phones, we've added sensors like light levels, barometric pressure for pressure, which can give you clues whether you're indoors or outdoors, or transitioning indoors or outdoors. Humidity levels, which can be of relevance for nosocomial infection. And we've mapped out, in our various studies, people's movement, how they move around the city. This is Saskatoon, you recognize, where they are indoors as well as outdoors. We can map out their contact patterns every few minutes if required, and we've done so. We can map how long their contacts take place. IFE is designed to be very customized, but a key component of this is the capacity to engage in reporting using the system. This is proactive reporting, so they can actually push buttons which are defined on a per-study basis to say, for example, I've just been exposed to tobacco messaging, or I've just taken my insulin, or I'm checking my blood sugar levels, or I've just encountered I've just had a set of wheezing and coughing if I'm asthmatic. They can report subclinical symptomology. I'm feeling lousy today. My stomach is bothering me. That might be a clue to something that's widespread but underreported directly, which is something like foodborne illness. So they can use this system to basically report things proactively in addition to this data that's being collected. They can also be asked questionnaires, so-called ecological momentary assessment, that go on a study-by-study basis to ask questions that might give clues as to their behavior. For example, and the linkage to other things that are picked up. For example, to shed light on the linkage between exposure to tobacco messaging, as reported by a button here, and cravings for cigarettes and, in fact, cigarette use. And we have a wide variety of sort of flexibility on this. By coupling this system with other components such as heart rate watches, weight scales, EEGs, we can get a variety of other types of data. So we can map out, for example, activity level over geography where social interactions take place, spaces within a facility where they take place, and by cross-linking it to weather and GIS databases, we can gain access to what services people are exposed to, link it to crime data or aspects of walkability, to various types of environmental sensors, traffic congestion, etc. So a system like this exhibits what are sometimes called the 4 V's of big data. Volume, it's a lot of data collected. Somewhere around 40 to 50 megabytes per person per day is typically collected by the system. On a per month basis, it's something about 1 million records per person per month or somewhat more these days. Volume. Velocity is often more important, how quickly the data is coming in. We're getting typically every 5 or 10 minutes or so, we get new data coming in. Social patterns, physical activity, aspects of social connections. That data may not all come in immediately in real time. It may be batched up, someone's got the phone off, or someone's out of cell phone range. But when they come back, we can collect that data. So velocity, variety. There's a wide type of data collected. Simultaneously cross-linked data on social context, where I am, how much physical activity I'm getting, for example. Very powerful if you want to understand some aspects of how the built environment, the social environment end up affecting things like physical activity. Or think in a nursing home context, a long-term care facility, where I am, who's nearby, by implications, what surfaces I may be in contact with, what equipment, or who else I might be in contact with physically. It can be very helpful for understanding risks of nosocomial infection transmission. So that's variety. The final component, veracity. I talked about the types of limitations on self-report for things like nutritional intake, physical activity, social aspects of social context, contact duration. These are things we can measure automatically with physical measures. So we can often get more accurate data. Not always, but in often cases. So the 4 V's of big data: volume, velocity, variety, veracity are features that we can often secure using this system. A foremost goal here, we built this system, long before we built this system, we went in our talk with our ethics board here. And we said, look, we can do this technically, but we want to talk with you about what's acceptable. What is an ethical way of pursuing this research? And they've partnered with us over the years in a very, very fruitful fashion. We're extremely lucky to have our ethics board compared to the experiences of many colleagues around the continent. And our ethics board early on flagged for us certain things that were off base, certain things that were very routinely to be accepted, and certain things that were in the gray area. And we've been staying within that and doing very well. Among other things, we offer a snooze option. Anyone can snooze this system at any time. If they want to opt out of data collection, they can do so. If they want privacy for the next 12 hours, they can get it. We have very strong on-device encryption, meaning if I got a hold of one of these phones and I tried to break and figure out what it was saying about a participant, even I'd have to work months to have a chance of doing that. And we do censor certain types of data so that we pick it up. All this work goes through informed consent. So we have a variety of value propositions. It's intensively longitudinal data on individuals, physical measures, cross-linked with all sorts of information, sufficient temporal resolution to pick up many effects, and we can kind of triangulate for multiple measurements. Very powerful. What can we do with this? Well, we can tease out the effects of different pathways affecting an intervention outcome. Is this intervention's positive effect on obesity largely due to changes in sedentary behavior and physical activity, or to where you're eating? You can support subclinical reporting. Think about foodborne illness, where most cases go unrecognized. Not only most, like 99.5% go unreported. You can pick something like that up by allowing people to report they ain't feeling well and then filling in the blanks. Where have they been recently based on the GPS? Where were they traveling? And you fill that in with their reports, you start to get a clue. Not guarantee, but you start to find patterns. They may that a bunch of people who have reported feeling ill have visited the same, Arby's within the past week or what have you. You might be able to connect exposures, for example, to poor air quality, fast food, tobacco promotion, other behaviors with outcomes more effectively. Those exposures in terms of your physical environment or social environment, you might be able to track how they lead to different outcomes. Understand the effects of an intervention on an individual and their behavior of that individual and different pathways that observed variability. For example, in women with gestational diabetes, why is it that some have quite adverse outcomes for themselves and for their child and others much less so? And this is one of the reasons we recently ran a study for women with gestational diabetes that we're currently working on writing up. One of the big things here is really accelerating and deepening learning from interventions, the capacity to distinguish why an intervention has an effect. Now, what does all this have to do with models? It has to do centrally with models, folks. First of all, models also provide us a way of trying to understand why an intervention has had effects. We can represent multiple pathways in this intervention. And we can compare that with what we see from these devices. So it keeps our models honest. But models most fundamentally can be used to make sense of this data, to link it into context. There's many types of models, but I want to highlight dynamic models. What is it this big data yields with dynamic models? Well, ladies and gentlemen, when I started doing dynamic modeling in health between 15 and 20 years ago, and even more so when I first started doing dynamic modeling in the social arena, which was over 25 years ago now. 25 years ago now. It was a very different world. We often built models without access to a lot of data. These days, we're increasingly being able to get data that pin the model down, that help ground it, that help pin down some of the parts that previously would have been a little bit speculative, a little bit uncertain. We have this rich grounding in observations, and we have a growing database, whether it's from electronic health records, whether it's from devices like IEPI, whether it's through online sources, social media behavior, that provide database for model parameterization and calibration, for being able to sort of let us estimate certain parameters involving individual behavior. And moreover, the big data can stimulate dynamic hypotheses on the part of the modeling, can help us sort of shape the modeling towards better theories of what's going on. Where do the dynamic models bring to bear? Well, they bring a huge amount, actually. They can help us kind of fill the gaps between sensors, capture regularities that underlie the sensor data. They can help us understand the distal implications of the sensor data. Think sedentary activity, physical activity, sedentary behavior, nutritional intake. What's the impact of that going to be down the road if that behavior is maintained? And they can help us determine how quickly we need to sample. This is one of the key things they brought to the table. We can actually take a model and simulate the effects of sampling more frequently or less frequently, and use that to guide how often do we need to collect data to have dependable insights with a model. Okay, so we're going to have to end here in just a few minutes. Suffice it to say, we've used big data together with dynamic models in several ways. One of the most powerful ways, ladies and gentlemen, is something that Anahita, who is right over there, is going to be talking about, although not specifically in the context of electronically sourced data. But it's this technique that brings together incoming data that's streaming in, maybe once a minute, maybe once a day, or once an hour, once a day, once a week, however often it comes in, it's a way of combining that incoming data with the model in a technique that regrounds the model. It sort of takes into account the data's imperfect, the model's imperfect, both are fallible, and tries to get a consensus view from both of them. It's called the particle filter. It's a type of sequential Monte Carlo procedure that derives from computational statistics, machine learning area. And basically it's a way of taking the model and keeping it grounded by new evidence. So rather than the model diverging from the evidence, as models inevitably do, as we talked about, because of stochastics and other factors, it keeps the model kind of constantly refreshed, updated with the latest understanding, so we can now look forward if we need to. And Anahita will be showing a case where she used that technique together with data from the H1N1 outbreak here and you're going to be looking at Winnipeg specifically, I think, right? Yeah, the Winnipeg data. Looking at how the particle filter can be used together with a model to allow the model to kind of look forward in the midst of an outbreak using that latest data and incorporating it automatically. So the model is always grounded with the latest data. And if we think about this electronic data, this big data, there's even more opportunities for that, ladies and gentlemen. And here's the prospect, ladies and gentlemen, that I wish to put before you. I wish to submit to you that we're entering a different world with these models. We're entering a world where it's no longer a choice of, do I build a model that takes a long, long time to build and is really, really accurate, or a model that I've had to assemble quickly with rough and ready data that will be just used for sort of high-level ahas. We're increasingly entering a world where you can assemble a model fairly quickly, keep it honest with incoming data on an ongoing basis, correct for any of its deviations, and work to enrich that model over time as new data comes in and as our understanding of the situation is enhanced. And increasingly, we're going to have access, whether it's through eHealth, databases that are generated by tools like IEPI or from social media interactions, et cetera. We're going to have access to data that will increasingly ground that model. But we're also going to have access to this incoming data that can keep even a rough and ready model sort of consistent with the latest data and ready to look forward to sort of assess trade-offs. Things that kind of keep the model learning from the evidence. So here, in the big data context, much of the excitement is about the velocity, the volume, the variety, and the veracity. But I think what also is due is a recognition of the fact that this data will be arriving on an ongoing basis can really change how we do modeling, change us from a situation where we build the model and then use it to a situation where the model is always being updated to incorporate that latest evidence using the type of techniques that Anahita will be presenting. Not right now. Don't worry about that. No worries. Anyway, you'll have people more appreciative of the talk when it comes. Anyway, so those are all the comments I have time to present right now because the hour is drawing near. Any questions from folks here before we transition to the sort of final components of the 2 days? Questions? Okay. If anyone's interested in learning more about IEPI, there are several figures circulating among the TAs who have tremendous knowledge of IEPI because they help contribute to it. But most of the students could help talk with you about it. Kurt, in particular, has done an amazing amount of work combining IEPI for health studies, but it's also looking to combine it with his modeling in a central way for his PhD thesis. Yeah, particularly in the area of tobacco control, including here in Saskatchewan, looking at this interaction of e-cigarettes and traditional forms of tobacco use. That's together with Erica Pens over in Ellis Hall here in respirology. Any questions? Okay. I know this is a little bit like a fire hose, isn't it? We don't call it a boot camp for nothing. Okay. Yeah, and even a fire hose gets a little tired at times. Okay, it feels like a fire hose for me too, I tell you. Okay. So we're going to. Oops. Yeah, I don't think I have a meeting now. At least I hope I don't. So where was I here? Okay, we're gonna have to do some. Oh man. Okay. Now we're in trouble. There we are. Okay. Good. So we're going to now transition to the final stage of the 2 days.